We have two different ways in which vectors can be represented, generally speaking. The first way is known as the column form. So if A is a vector and it is defined on a three-dimensional plane surface, then A can be represented in column form as X, Y, and Z. Now there's another way around in which we can represent vector A, and that is by representing it in unit vectors. In this case, we will need to introduce the letter I, J, and K, which serves as the unit vector along the direction of the X, Y, and Z axis. So therefore, vector A can also become xi plus j or yj, then plus zk. So in either case, we are still referring to the same thing. So keep that in mind. There's one more thing you need to know about operation on vectors. How do we add two vectors? How do we subtract vectors? When a scalar is multiplying the vectors, what are we expected to do? In fact, what would the scalar, what would it meant to do? So let's see that. Consider a vector A to be x1, y1, z1, and vector B to be x2, y2, z2. If you are to compute vector A plus vector B, then all you are meant to do is to add each of the corresponding coordinate values. So this will simply be x1 plus x2, then y1 plus y2, then z1 plus z2. And that will be your final answer. This process also works if you have to compute A minus B. The only difference is just that instead of having positive sign respectively, you'll be having negative sign. So what if instead you have to find something like 2 multiplied by vector A, then minus 3 multiplied by vector B. So which means you must compute 2A first, also 3B before subtracting them. So how do you want to find these two? It's pretty much straightforward. All you are meant to do, let me create a null space first. So to determine 2A, what you are meant to do is to multiply 2 by the vector A. So we are multiplying 2 by x1, y1, z1. So what is the 2 meant to do? It's meant to multiply each of these coordinate value respectively. You have to distribute it as if you are expanding a bracket. Well, the order will change anyway. So that will become 2x1, 2y1, and 2z1. Same thing will apply to that of 3b. Just distribute the 3 and have your answer with you. And once that is done properly, you can compute what you are expected to compute. And that is it. Now, there's what we call modulus, or sometimes known as magnitude of a vector. In case you're asked to do that, how do you want to find the modulus or magnitude of a vector? If vector A is also defined on a three-dimensional plane shapes or plane surface rather, to be, for instance, let me give a value 3i plus 4j, then minus 5k, for instance. What if I'm asked to determine the magnitude of vector A? This is the symbol we use to represent the magnitude or modulus of vector A. This is pretty much straightforward. All you are meant to do is to find the square root of the sum of each of the components of these unit vectors. So therefore, typically the squares, I'm taking the squares of 3 plus the square of 4 plus the square of negative 5. Okay, by 5. And that will eventually become the square of 3 is 9 the square of 4 is 16, and the square of -5 will become 25. So adding this together, 9 plus 16 is 25, and 25 plus 25 is 50. So finally, this will become a root of 50. Since the sword can be simplified, we can turn it to the root of 25 times 2, which will eventually be 5 root 2. And that will be our final answer. So now you know how to determine the magnitude or modulus of a vector. So now, sometimes you might not be required to find the modulus alone, but also be required to find the unit vector of that given vector, okay, in the direction or in its direction. So what did they mean by that? In fact, what are you expected to do after determining the magnitude of that vector? In case you are asked to find the unit vector of that given vector, then all you need to do is to divide the vector by the magnitude. So to determine the unit vector of A, which will usually represent as this, that's indeed equals to vector A divided by its magnitude. So therefore, the unit vector of this vector will end up being this. So vector A is 3i plus 4j and minus 5k. And I'm dividing that by its magnitude. Its magnitude turns out to be 5 root 2. You can leave your answer this way. If you want, you can distribute the 5 root 2 and end up having 3i divided by 5 root 2, then plus 4i divided by 5 root 2, 4j, then minus 5k divided by 5 root 2. And that will be your final answer. Before we go over some examples, I would like to talk about some other things that I think you have to be familiar with. And one of it is the resultant vector or resultant as a statement. Sometimes you will be given some pairs of vectors and be required to find the resultant vectors of this vector. So what are you expected to do? Take for instance, vector A is 3i plus 4j. Assuming it is defined on a two-dimensional plane surface, and vector B is minus 2i minus 5j. If you are asked to determine the resultant vectors, what are you expected to do? All you need to do is just like as if you want to compute vector A plus vector B. So just add the vector together. To add two vectors that are defined in their components, add those corresponding component values respectively alongside the unit vectors. So 3i plus negative 2i, that will be indeed equals to I, and plus 4j plus negative 5j, and that will be indeed equals to negative j. And that is the resultant vector. Hopefully you got that. Now one more thing we need to discuss in this video that you need to be familiar with about operations of vector is what we know as the direction cosines. Okay. So what do we mean by direction cosines? It's like the angle at which a certain vector subtended with each of these axes. What are we saying makes sense? If a vector is defined on a two-dimensional plane surface, for instance, to be xi plus yj, the direction cosine, which is the angle subtended by vector A on or with the x-axis, is given as cos alpha, and that is simply equals to the value of that coordinate, the value of x, divided by the magnitude of the whole vector. Similarly, the angle subtended by vector A with the y-axis will be represented as cosine beta, and that is simply equals to the value of y, whatever you see to be attached with j, divided by, well, you need to carry the sign along. If there's negative, make sure you take that along. Y divided by the absolute value of vector A. And that is how it works. So now, to understand what we have been discussing right from the beginning of this video, let's try to analyze them with some examples. Consider three vectors. Vector A to be given as I plus j minus k, and vector B to be given as 2i plus 3j plus 4k, and vector C to be given as 5i minus 4j minus 3k. And let's say, for instance, we are to determine 2a plus 3b minus 3c. I wrote 6. And also, let's take, for instance, that is option A. Then option B, we have got 2. We are to determine A plus B minus C. Then we have got 3. We are to determine the absolute value, which is the same thing as that of the magnitude or modulus of 2a plus 3b minus 3c. Then, second to the last, which is the human figure 4, we have to determine the unit vector in the direction of a plus b minus c. Okay, once we get there, if we get what we mean by in the direction of a plus b minus c. And the last and the least, we have to determine the direction cosines in the direction of 2a plus 3b minus 3c. Okay, hopefully you can figure that out. So these are 5 different questions before us that we need to simplify. So let's begin with the first one. 2a plus 3b minus 3c. I've copied out all the questions, so you can also have it copied in your note, because I'm going to get it off the questions so as to have enough space to solve the problem. Feel free to pause the video in order to have enough time to copy down everything. So let's compute the first one, that is 2a plus 3b minus 3c. To compute this successfully, we need to first of all compute 2a separately, 3b separately, and 3c. So 2a is just as if we are multiplying each of the components by 2. So the components of this vector are all 1s. And 2 times 1s respectively, that will be 2i plus 2j and minus 3k, y3 minus 2k. And for this, we need to multiply each of them by 4. By 3. This by 3, this by 3, this by 3. So that's going to be 2 times 2i, that's 4i, 3 times 2i, that is 6i. Okay, why am I checking something different? Then 3 times 3, that's going to be 9j plus 9j. Then 4 times 3, that's going to be 12k plus 12k. I hope that is absolutely right. Perfect. Now, on to 3c. 3 times 5i, that's going to be 15i. Then 3 times negative 4j, that's going to be negative 12j. And lastly, 3 times negative 3k. That will be negative 9k. Perfect. So now we can compute the operation 2a plus 3b minus 3c. So what we need to do is to add each of this and subtract the last one from it. But for easy understanding, I would like to compute 2a plus 3b first. 2a plus 3b is just as if I'm adding each of this. So there's going to be 2i plus 6i. So that will result in 8i. Then 2j plus 9j, that's 11j. Then negative 2k, positive 12k, that's going to be positive 10k. Perfect. So now I can now subtract 3c from it. Okay, so 3c is equals to 15i minus 12j minus 9k. Perfect. So 8i minus 15i, the negative will affect each of this. You understand? Okay, let me just do that. Negative 3c, that will be negative 15i, positive 12j, then positive 9k. Okay, the negative will affect the 15 to become negative, will affect this to be positive. Similarly, this will also be positive. Okay, perfect. So now let's continue. So 8i minus 15i, that will result in 7i, negative 7i, plus 11j plus 12j, that's plus 23j, plus 10k plus 9k, that's plus 19k. And that is our final answer. Round 2. We are to compute a plus b minus c. So we are to compute vector a plus vector b minus vector c. So what would that be? We don't really need to do much in order to find the solution to this, since there is nothing like scalar multiplication. So let's just add them respectively. But for easy access to the final answer, in order to avoid some mistakes, let's compute a plus b first. What will be a plus b? So we can just add them respectively, like correspondingly. So that will be I plus 2i, that's 3i. Then j plus 3j, that will be 4j. Then negative k, positive 4k, that will be positive 3k. Perfect. So that's it. Now we can now bring or determine negative c as well. Negative c is as if we are multiplying negative by the whole vector c. So let me try to put that within a parenthesis. So that will be negative 4j, negative 3k, and that will be negative 5i, positive 4j, positive 3k. And now we can add this to this. So finally, our final answer will be 3i plus negative 5i, and that will be negative 2i. Then 4j plus 4j, that will be 8j. Then what about 3k plus 3k? That will result in positive 6k, and that will be our final answer. So on to round 3. In round 3, we are to determine the modulus or magnitude of 2a plus 3b minus 3c. So earlier we got 2a plus 3b minus 3c to be equals to 8i plus 11j plus 10k. So, and I said, to determine the modulus of a vector, all you need to do is to determine the root of the sum of the square of each of the components of the unit vector present in that given vector. So that will be 8 squared plus 11 squared plus 10 squared. The square root of 8 is 64, while the square root of 11 is 121, and that of 10 is 100. So let me add them up on a 30 order. 121 plus 100, that's indeed equals to 221. And finally, final answer is 285. I will leave it for you to simplify. Check if you can reduce this word. And that is the answer to the third question. Now on to the fourth question, which we had to determine the unit vector in the direction of the sum of the vector minus that of C. Okay, what am I saying? Makes sense? We have to determine the unit vector in the direction of vector A plus vector B minus vector C. So what are we expected to do? Like I said, to determine the unit vector of a certain vector, if A is a vector, for instance, the unit vector of vector A is given as the vector A itself divided by its magnitude or modulus. Okay, so earlier we got this vector to be equals to negative 2i plus 8j plus 6k. To determine its units, generally, we need its magnitude. And to determine its magnitude, that's not something new anymore. All we need to do is to take the square, the sum of the square of all the stuffs. So that will be the root of 4 plus 64 plus 36. So 36 plus 4 is 40 plus 64, that's 104. That's the root of 104. I don't think 104 can be simplified to the simpler form. By the way, that's an assignment for you. Feel free to check that out. So the magnitude of vector A plus vector B minus vector C is the root of 104. Now we can determine the unit vector. So the unit vector, what I will do right now is to express it as this. The unit vector in the direction of this vector will be given as the vector itself, which is negative 2i plus 8j, then plus 6k, all divided by the root of 104, which you can actually express it as 1 over root 104 in the bracket of negative 2i plus 8j plus 6k. That is our final answer. By now, you should have been getting familiar with the operations that we have in vectors. So let's answer the last question. However, I changed my mind. So you are going to use that as a practice problem. Find the direction cosine in the direction of 2a plus 3b minus 3c. Let me know your solution in the comment section below. Thanks for watching. See you guys in the next video. Bye for now.